Hi dear friends and viewers, welcome back to our channel and Vinay Kumar Basics of Physics. Dear friends, in this video we are going to discuss about the one of the important 4 marks question in the chapter of mechanical properties of fluids that is related to the intermediate first year physics. So children, my request is if you want to learn something you have to watch the video very carefully up to last without any skip, okay? So then only my content will reaches you. So without late we are going to the topic. The question is children, how the pressure can varies with the depth. That is the topic here children. Let's go for that. Explain variation of pressure with depth. That is the we are going to discuss here. Dear friends, this is the one container. In that one cylinder is there. Clear? In a steady fluid, one cylinder should be is as shown in figure. Then on that cylinder, so this is the one cylinder. That should be where it is there, children? Yes, that should be in a steady fluid. Then here the fluid can apply the force along the 4 sides like this. This is I am going to say F1. F1 force is acting on the top surface of the cylinder and F2 is the force acting on the cylinder in upward direction at the bottom, and F3 and F4 are the forces acts along the length side at the same heights. If you can take here, both should be parallel. Here the fluid can apply the force here like this. The forces are because of steady fluid, you have to remember that. That's why here the forces which are taken along the length side, A, B I am showing length and CD also length. Now these are equal in opposite directions, That's why these forces should be equal to these one and they are in opposite directions. That's why the side forces are having net force is 0. Clear? That means what? There is no horizontal forces acting along the cylinder. You have to remember that. They are acting but net force is 0. And the next thing is what? There is here some force is acting in downward direction here, acting on this particular area A1, and this is the force acting on the particular area A2. So when the force is acting on particular area, that can create the pressure. That's why on top surface pressure is what rate pressure? P1 is equals to F1 by A1. Force by area is what we call pressure. And similarly here now the pressure on the cylinder at the bottom. So what it is, right? Simply here F2 force is acting on particular area A2 and this particular area A1. So that's why here the pressure acting on the bottom surface of cylinder, pressure what is? P2 is equals to what, right? This is the A1, this is now F2 by A2. That's why here from that equation the amount of force should be written as F1 is equals to P1 A1, and here F2 is what? P2 A2. F2 is equals to P2 A2. So this F1 force is acting in downwards, F2 force is acting in upward. That's why in this case net force can be written as here what it is? F2 minus F1. Here we are saying that F2 is greater than F1. Why? Because the buoyancy force what it is acting in upward direction. Clear? So F2 is acting in upward direction and F1 is downward direction. Here F2 is more than the F1. You have to remember that. That's what I read here. Net force is F2 means F1. What is F2? P2 A2 minus P1 A1. So this is the equation number 1. So you have to remember, children, even though that there is some net force acting on the cylinder is not moving in upward direction or not moving in downward direction or not moving towards the any sides. Already what we discussed, there is no net force along the horizontal directions, but there is only net force is in vertical direction. So even though the vertical force is acting, there is net force acting along the vertical direction, but there is no moving of the cylinder, either it is in upward or downward. Why? Why means that net force is balanced by the weight of the cylinder, That's why here what you have to write? So net force is balanced by weight of the cylinder, Got it, children? So that means what? Simply here, if you can take mass is the m is the mass of the cylinder is what? M. Then how we can write weight? Weight is equals to mg. What is weight is equals to mg? That's what I write here. mg is equals to P2A2 minus P1A1. This is the equation number 2, children. And dear students, all of you know what is density? Density is equals to mass per volume. We can write mass per volume. Again, mass means what? Right here, rho into V we can write. That's why I am going to write, instead of mass, what do you write? Rho into V into G is equals to P2A2 minus P1A1. Clear? And in next thing we have to remember, children, one more formula it is there. V is equals to AH. What is V? V is the volume of the cylinder, and A is what? Area into height. So children, to check whether it is right or wrong, we have to check it. What is the V? Volume. Its unit is what? Meter cube. And now A into H. A is what? Area. Its unit is what? Meter square. And height is what? M. Then what, right? Meter cube. So meter cube is the unit for AH. That means what? Volume. That's why instead of volume, what we can write? AH we can write. Therefore, instead of V, what write? AHG is equals to P2A2 minus P1A1. Clear, children? So after that, you can observe here in this figure, what you have to say? A1 is equals to A2. Both are same. Cylinder is having the uniform area of cross section. That's why what you have to write? A2 is equals to A1 is equals to A. So what you have to write here? What write, children, here now? Simply let A1 is equals to A2 is equals to A. Then substitute here rho AHG is equals to, here what I am going to say? P2A minus P1A. A2 means A, A1 also A. Then among these two, which is common? We can write like this: rho AHG is equals to A is common. Then what, right, children? P2 minus P1 of A cancel. Then what we got, children? So dear students, if you want to prepare the notes, just pause the video and prepare the notes. So I need some space, that's why I am erasing this one. So children, what we have now? Rho HG is equals to P2 minus P1. So from that, what, right, children? P2 is equals to, what is P2 here? Pressure at the bottom of the cylinder. What is P1? Pressure at the top of the cylinder. Therefore P2 is equals to what, right? P1 plus rho g h. So P2 is equals to what? P1 plus rho g h, children. So from this equation, what you have to say? Here what we are saying, at the top what it is the pressure? P1. At the bottom what is the pressure? P2. So here we are writing something, P1 plus something we are writing. That means what? The value of P2 is greater than P1. So that's why from above equation, what you have to say? P2 is greater than P1. That means the pressure of the body, increases with the depth. So this is the answer you have to write in the examination, children. So simply from the pressure of the body is increased with the depth. So P2 is equals to P1 plus rho g h. Clear, children? So children, in another special case it is there from the same equation. What it is means, simply note one more condition is there for this one. Note top surface is exposed to the air. So if top surface is exposed to the air, then the above equation can be written as like this. Here P2 is equals to PO plus rho g h. P2 is equals to what? PO plus rho g h, or instead of P2 you can write from the above equation what I would write, P2 is equals to P and P1 is equals to PO. Then the equation is what, children? Here P is equals to PO plus rho g h. So dear students, here PO is the atmospheric pressure. What it is? Atmospheric pressure. So children, this is the answer for what? Variation of pressure with depth. So when pressure is increased means what? When we are going from top to down in water, steady fluid, the pressure is increased with the depth. When depth increases, pressure also increases. So dear students, I hope you will understand. If you can understood this one, like, share, comment the video. And dear students, please share my channel to your friends also. If you can understand, you can share same thing to your friends. So keep continuing your support. Thank you for watching.